In this video, we will explore how to figure out the area in two situations. One is the area bounded by x-axis and the function. The other one is the area bounded by two functions. Let's go to the first one. Area bounded by x-axis and a function. The formula will be this. Either you put the absolute value to the function, then you from A to B, or you will find the x-intercept, then do this separately. Because as you know, when the function is above x-axis, then you will get the positive value for definite integral. When the function is below x-axis, the value for definite integral will be negative. So when we use the graphing calculator to get the area bounded by x-axis, we will choose the absolute value 1 because this is easier. Now let's do one example. Find the total area of the regions contained by y equals x to the third power plus 4x squared minus 5x and the x-axis. First of all, we will put this function into graphing calculator. So we put this function into y1, then we graph. The area we are looking for are two parts. One is above x-axis, the other is below x-axis. So you need to figure out the x-intercept on the very left side and also on the very right side. You can use the second trace, go to this 0 to figure out that x-intercept. But I want to show you use polyroots, which is so much easier to figure out the roots for any polynomials. So we go to apps. Look for that polysimultaneous 2. It's here. So we put the enter. Polyroots finder. Enter. This is x to the third power, so we put the enter. Then just go to this next. Go to graph. A3 will be 1. A2x squared will be 4. Then for A1 will be negative 5. No constant number, therefore A0 will be 0. Then go to solve. Now, there are 3 zeros or 3 x-intercepts for this polynomial function. We use the very left one, that's negative 5. Very right one is 1. Therefore, we go back here, second mode. Go to 6, quit. Then go to math, 9. This will be from negative 5 to 1. Then absolute value, math, number, here. Because we already put the function into y1, therefore we do alpha trace y1. Then go to this dx, enter. You will get this answer. the calculator is not accurate enough. You can change this into fraction by doing 73.8333, keep going 3. Then you go to math, enter, enter. You will get an accurate answer to this definite integral, which means the area enclosed by x-axis and the function. So how can we figure out the area enclosed by two functions? Here are formula. If we have a calculator, I prefer use this one. You just need to put the difference of two functions into absolute value. Then get the very left this intersection and the very right intersection from A to C, then do the definite integral. You will get the answer. But if you don't want to use the absolute value, you have to change this shaded area in two parts. You have to be very careful which function subtract which function. For example, from A to B, you could say f of x is above g of x. Therefore, you will get integral from A to B, f of x minus g of x dx. In this way, you will get this area is positive. For B to C, since g of x is above f of x, therefore, you will use g of x subtract f of x while you do the definite integral for the interval B, C. Now let's go to example. We have these two functions, y equals x squared minus 3x and x minus 3 times x minus 1 times x plus 2. We want to figure out the area of these two functions enclosed. y1 is x squared minus 3x, y2 is x minus 3x plus 2, and x minus 1. Then go to graph. We need to figure out the intersection. This intersection and this intersection. Just the very left intersection and the very right intersection. So we do second trace. Go to 5. Then move the arrow close to this intersection. We will do enter, enter, enter. So the x-intercept will be negative 1.41. Use 3 significant digits. Now let's figure out the intersection on the very right side. So we do second trace. Go to 5. Move the arrow close to that intersection. Then you put the enter, enter, enter. So you get x equal to 3. Now we quit. We go to math 9. This will be negative 1.41. The upper limit will be 3. So we will put the absolute value, math number, enter. Then go to alpha trace, use y1 minus alpha trace y2. Then go here is a dx. enter. This will be the area we are looking for, enclosed by those two functions. For the absolute value, you can use y2 minus y1 here. It doesn't matter.